Hey Valley Metal, welcome back to another math lesson. Today we're going to learn about the greatest common factor. Let's start off with something fun though. Here we go. Is it true that a duck's quack doesn't echo? I've heard the rumor. We'll explore it and bust the myth or prove it to be true. Officially, our target today is 4.2a. I can find the greatest common factor of two or more numbers. We're getting up there, getting a little harder than 5th grade. Let's do this. All right, let's start off with a question. See if you can answer this. The cheerleaders are making spirit ribbons. Blue ribbons come in 24-inch spool. Red ribbon comes in a 30-inch spool. And gold ribbon comes in a 36-inch spool. Let's stop for a second. They've given us a graphic to look at here. The cheerleaders want to cut strips of equal length and use the entire spool for each ribbon. What is the length of the longest piece of ribbon that can be cut from each spool so that there's no leftover? So they want to cut ribbons. They're all the same length. If you think of them cutting them this way. You think about that. This problem here can be solved if we know what the greatest common factor is, and we'll come back to it at the end. Let's do some vocab. Greatest common factor, what is it? It's the largest factor that's shared by two or more numbers. If you take a look at the numbers 6 and 12, for instance, the greatest common factor is 6. If you were to make two factor trees, that's what you find out. The greatest common factor for 6 and 9, though, is 3. That's the largest factor that they share. Little trick I always do is I always look at the smallest number and see if it goes into the larger number. Oftentimes it will, and then that smaller number is your greatest common factor. Let's take a look at a couple of methods here. First of all, you can do the method that most people use. They just take and factor out the numbers, like 18, that's 1, 2, 3, and 6, 9, and 18. And they factor out 48, 1, 2, 3, 4, 5, 6, 8, 12, 16, 18, and 24. So they've listed the factors out. They've even taken and made the common factors in red here, and then they just look for the largest one, and that is obviously 6. So the common factors are 1, 2, 3, and 6, and 6 is the greatest or the largest shared factor. Greatest common factor can be translated into more simplified language I would use in 5th grade, the largest shared factor. All right. You can also write the prime factorizations, and this is a slick method here too, especially for larger numbers. Take 18, and that factors out in prime factorization as 2 times 3 times 3. Take 48, that's 2 times 2 times 2 times 2 times 3. And then you look for the common factors. Well, each of them has 1, 2, at least 1, 2, and 1, 3. So now, notice how this has 2 3's, but this only has 1, so I can't circle that. This has many 2's, this one only has 1. So you just circle the ones that are shared. If there's 2 2's, you could circle 2 2's. In this case, there's only 1. So then you take those prime factors, those shared prime factors, and you multiply them together, 2 times 3, and you get 6 again. All right, there is a third method, and I call this one Danny D's Lazy Boy Special. When you say, what is the greatest common factor between 18 and 48? Well, I factor the smaller number. Sorry about that. I factored the smaller number. So I do this in my head. I had 1 and 18, 2 and 9, 3 and 6. Then I write those factors out in order. And then I study the list of factors, and I say, which is the largest one that is also a factor of 48? And of course, I start out on this end. Does 18 go into 48? Well, 2 18s is 36. No, it's going to be too big. Does 9 go into 48? 9 goes into 45. Does 6 go into 48? Yes, it does. 6 times 8. 6 is your largest. So this way here, I'm okay with you if you use this method here. I think the more proficient you become with it, the better this method is. So you choose a smaller number, factor it out, and ask yourself specific questions about each one of those and find the largest. All right. Let's take and have you apply a little bit of your knowledge here. I'm going to demonstrate all 3 different methods here. What is the greatest common factor of 48 and 36? Go ahead and you figure that out. I'm back. All right. Let's see what I did here. Well, first of all, I took and factored out 48, and I factored out 36. I used that first method. All right, got all my factors here. I just left them in the factor tree because that way I've got the numbers going straight down. Here are the greatest shared factors or common factors: 1, 2, 3, 6, 1, 2, 3, 4, 6, and 12. Obviously, whatever number appears at the end is the greatest common factor. GCF is 12. It's a miracle. All right, let's have you try another problem. Why don't you try this one using prime factorization? Go ahead. All right, well, if we prime factor this one, it'll break down into this. 3 times 9 is 3 times 3 times 3, and then 45 is broken down into 5 times 9, so you got 5 times 3 times 3. Well, in this case, I've circled 2 3's that actually are shared. So the greatest common factor is going to be 3 times 3, or 9. Alrighty? If you made factor trees, you'd get the same answer. Alright, let's try one more. The greatest common factor, go ahead and do the Danny Dudley lazy boy method on this one. For 3 numbers, 30, 45, and 60. Go. I'm back. Or, I'm back, my Arnold Schwarzenegger. All right, let's see what I did here. I factored out the smaller number using the Danny D Lazy Boy Special. And then I start up at the top. Will 30 go into 45 and 60? Well, 30 will go into 60, but not 45. No, it will not. Will 15 go into 45 and 60? Ding, 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 ding. Yes, it does. 15 goes into 45. That's 3 times 15 is 45, and 4 times 15 is 60. Yes, my GCF is 50. Wasn't that simple? I love that. Whenever I can help you shortcut something, I like doing it. All right. Quick reteaching for those of you who missed it. If you don't know how to do this, I suggest this method here, the very first method. Make a factor tree for each of the numbers and look for those numbers that are shared. So for 30, I made a factor tree, and for 54, I made a factor tree. If you don't remember how to make a factor tree, go back and check out video 4.1a. All right? Circle the ones that are common. Find the largest one that is circled, and that is your GCF. So for 30 and 54, once again, it's number 6. All right, let's get back to our original question about the ribbons. All right, well, using GCF, and they did the prime factorization method here. They took 24, and they got 2 times 2 times 2 times 3. For 30, they had 2 times 3 times 5, and for 36, it factored out in to be 2 times 3 times 3. If you look for the common factors, see how they broke that up to make it a little bit easier. They slid it over. Break it up, you got 2 and 3. So once again, the GCF for 24, 30, and 36, the greatest common factor is 6. So if you cut the ribbons in 6-inch lengths, you will have used every bit of your ribbon, and you will not waste any, and all of them will be 6 inches long. All right, let's go to the just for fun question. Is it true that a duck's quack doesn't echo? Oh, I forgot. Sorry. Ticket to the show. Here you go. Take a pause for a second. Find the greatest common factor for these numbers. 24 and 40, 30, 48, and 60. I'll stop for a minute. Okay. Now to the ticket, or to the just for fun question. Is it true that a duck's quack doesn't echo? All right, I had to go to an online source for this. I got a video that actually explores it. Cool, we like video time. All right, here we go.
Is the internet theory that a duck's quack doesn't echo true? It's a favorite blogger's question. But is it the dog's honest truth? Or is it a load of quack? Meet Betsy. We took her to an acoustic laboratory in Sydney, Australia, and put her in a reverberation chamber, which can create an echo from the smallest of sounds. Betsy's big moment. And yep, there's an echo.
All right, well, we busted that myth. Sorry about that. No need for you to watch the commercial for Dickies jeans. All right, I hope you enjoyed your evening. You learned something about the greatest common factor. Thank you. Bye.